Bitcoin is programmable money, and every time you spend Bitcoin Cash, you are executing a program. These programs are also called contracts. To spend Bitcoin Cash successfully, the contract must execute successfully. Here is a small program to add two numbers together. And we start by pushing the number 1 to a stack, and then we push a number 2 to the stack, and then we run a opcode called opcode, which adds the two together. And the contract code is complete, but is it a valid contract? No. No, because for a contract to be valid, there must be one number on the stack, and that is the number 1. Here is another program where we add the number 1 and 2 together, and then we check if it's equal to 3. And finally, at the end of the program, we have the number 1 on the stack, and the contract executed successfully. I thought it would be a fun exercise to attempt to write the shortest program possible and see if we can execute it, and see if anyone else has written it before us. And I've identified a few, so I thought we just should try it out. The first program I'm going to try is to simply just push the value 1 to the stack using op true. I'm going to send some coins to the contracts. And we have a successful run. So let's have a look in the Block Explorer. Looking at the Block Explorer, we can see that this contract has had 803 transactions. So we are not the first ones to try out the contract op true. So here is us 3 minutes ago. So we are the first to use this contract in 3 years. So we are not the first to use it, but we are first in 3 years. That is something. The next program I want to try is one of the new opcodes, op input count, tx input count. Okay, let's try it. And we need to send some coins to it. And it was successful. Let's have a look in the Block Explorer. And here we have it. I was here in 2022. Woohoo! We are the first to use this contract. The next single opcode contract I want to try is one of the new opcodes, optx version. Also successful. Let's see if we were the first to use it. So it's 2 transactions, both are ours, so we were also the first to use this single opcode contract. I believe that we should be able to set the lock time of the transaction to 1, and then use optx lock time to push the value 1 to the stack. So let's try that. The contract script is optx lock time. And then I have to slightly manipulate the program to see tx and lock time equals 1. Let's try it out. And it was successful. And let's see if we were the first again to claim this single opcode contract. And yes, we were first to claim optx version, no, optx lock time. There is one more single opcode contract that I can think of, and it is op input index. But for this one, I have to modify my program slightly, because I need to spend coins from this contract as input number 2. Because input number 2 is the value 1. So to do that, I'm going to use tx lock time again as a first input. So here is the contract we want to claim. And let's go here and add a additional input. I'm going to find the tx lock time contract again. So optx lock time is input number 1, and then we have op input index as input number 2. No, I have a bug. Let's try again. Script seek not push only. Oh. Well, that is true. Why is that true? Maybe, oh, I need to maybe like this. No, that's not it. Okay, it actually worked. Oh, that is awesome. Let's check it. Are we the first? Of course we are. Okay. Oh, I forgot to change the view. Sorry. Here is the Explorer. And we are the first to also claim this opcode as a single opcode contract. Okay, I hope you enjoyed this. If you know of any other single opcode contracts without inputs, tell me in the comments. Perhaps if this was interesting, we can do more opcodes that actually take some inputs as well. Okay, thank you for watching.